So now, they've just reminded me, at the top they give me a picture of the unit circle, and they've reminded me of what I already know. Sine is y, cosine is x, tangent is y over x. They reminded me of my reciprocal values. So then we're just going to graph what our trips around the unit circle look like. So this particular table is just meant to help you graph it. So sine is your y value. This is like ridiculous easy. Sine is your y value, so it's 0, negative 1, 0, 1. Alright, so now that I have those, disregard this middle point. They were just helping us get our way around the unit circle. What we are actually graphing now is theta and sine theta. If you look at your graph down here, it is no longer the x-axis, it is the theta axis. And your y-axis is now the sine theta axis. So this first thing is my first ordered pair, negative pi 0. So I'm going to go to negative pi 0 and put a dot. And go ahead real quick and just plot all those points.
Do you want me or us to connect it?
Actually, no, and I will explain to you why in just a second.
Field learning. Oh wow.
Now, the reason that I did not have you connect the dots is because if we connected the dots, we would be tempted to just make them kind of like the one we just did. They would look like peaks and valleys and be like it would look like this. You would probably have connected them like this. Because in our world that makes perfect sense and that's how we connect things. But what this really looks like, and I'm going to put it up because I am a horrible grapher, y'all know that. So what it really looks like is this. It's a wave. That's the sine wave. So it's curved. Now if you think about it, this makes perfect sense. We are graphing what sine is. Sine is the y value, right? So as we go around the unit circle, the y value is positive until you get to pi, and then it is negative as you go around. And then at 2 pi, it goes positive again. So if you look at our wave, it's positive until we get to pi, and then it's negative. Does that make sense? Yeah. And it makes sense that it's curved because it's a circle. We're going around and around and around. So it makes sense that it's a wave, yeah? Okay, so now do the same thing, but this time we've switched to cosine. So now when we fill in our ordered pairs, this time we're looking at the x values. So fill them in and plot them. And now you know it's supposed to be curved. So go ahead and connect the dots. Curvy if you can. I'm a horrible grapher, so I totally understand. Mine never look like they're supposed to. Why does it look like a heart rate monitor? That's what mine always look like. Of somebody with a condition. With a bad condition.
Like it's annoying me because I can't get it right. No.
Okay, so cosine. Now this, you can see them both up there at the same time. Cosine looks like this, which also makes perfect sense. We're graphing the x values here. So if you think about the x values, they are only positive until we get to pi over 2. And then they go negative. And then they stay negative, and they don't go positive again until 3 pi over 2, and they go positive. So if you look at it, it makes sense. They're positive until pi over 2. Then they stay negative till 3 pi over 2. And then they go positive again. So it goes around and around the unit circle. That's why it's curved. So on the back, if you'll flip over to the back, we're going to put them in our calculator. Now, on your calculator, there is there are a couple things you need to know. Number one, it needs to be in radians. The graphs do not look nice if they're not in radians. So put your calculator in radians if you're not already there. And the other thing is, after you plug it in, when you hit zoom, I don't know where my inspire is. When you hit zoom, there's a button that says zoom trig. If you will hit zoom trig, it will put your values. Actually, I really need to know where my inspire is. I'm going to borrow one of y'all's real quick. Since I'm videoing it. Let me, Travis needs that real quick. Now let me borrow Austin's. Travis needs to hold this. Okay, so I'm going to put in sine x.
Yeah, the title of that, by the way.
Oh, nice. I didn't even notice it. Okay, so I hit sine x, and then if you hit, and there's my sine wave, but I'm going to hit menu, and on my zoom window, if you see number 8 is zoom trig. If you'll notice, now it's counting by decimals, but notice what this last decimal is. 6.28. What is that?
2 pi.
2 pi. So this is 1 trip around the unit circle. So it kind of helps. Now, another thing that might help, this particular worksheet was done based on the 84. And on the 84, it doesn't give all these little hash marks in between. So if you want yours to look like theirs, I could hit menu and window zoom. And on my window settings, I could, instead of it to scale auto, the way that that is scaled, there's a hash mark at every half pi. So I can plug in pi divided by 2, and it should give me hash marks at every half pi, just like the worksheet does. Yeah. It gives you the decimal version, but each of these hash marks represents a half pi. Does everybody follow me? Okay, now, on the x-axis, it is counting in radians. Pi, half pies, 3/4 pies, all that stuff. But on the y-axis, it's just counting 1, 2, 3, 4, 5, just like normal. So we're just going to answer these questions based on that. So, what is the y-intercept of sine? Looking at the graph that you got there.
0.
0. Where do the x-intercepts occur?
At pi's.
At the pi's. So at pi, and then again, another one occurs at 2 pi and 3 pi. So you could just put at the pi's. It really wouldn't be an apostrophe. Sorry. Fix my English. It's just pi's with an S. It's not possessive of anything. Pi does not know anything. Okay, what appears to be the domain of y equals sine x? Negative infinity to infinity, or all real numbers, because we could go around and around this unit circle as many times as we please, either in the positive direction or the negative. What about the range, though? Negative 1 to 1, and it is included, because it actually touches those places. This would be negative 1 to 1.
But is that the reason? Because it's still...
Yeah, because our radius is 1, and so as high up as it can go is 1, that's it. Okay, so what value of x does the function reach a maximum? At the pi over 2's. Now, it isn't just the pi over 2's, because that almost would imply that it happens at 3 pi over 2 and doesn't. It happens at pi over 2, for sure. And then what? Where's the next place that it occurs? 5 pi over 2. It happens at negative also, if you go backwards. It does. It does. Because we start with pi over 2, I'm just going to go in the positive direction. But it does go into the negative direction also. It happens at 5 pi over 2. It is going to happen again at 9 pi over 2. And again at 13 pi over 2. What would the next one be? 17 pi over 2. What am I adding each time? 4. 4 pi over 2, which is what? 2 pi. Where would that come from? A full trip around the unit circle. So this is periodic. Its behavior repeats every time it goes around the unit circle again. Okay, so at what values does the function reach a minimum? So where's the first minimum? And you can give the negative one if you see. If the negative one's the first one you see. What's negative? Right, it's at positive 3 pi over 2, or if you start at the negative one, negative pi over 2. Now we know this thing is going to repeat every time it goes around the unit circle, so the next one would be at 3 pi over 2. And then 7 pi over 2. And 11 pi over 2. Because it repeats every 4 pi over 2. And that can just dot, dot, dot. Alright, here's a good question to jog your memory. Is sine even, odd, or neither?
Odd.
How do you know?
So you rotate it and it matches.
Very good. It is odd because it has rotational symmetry. If you turn it upside down, it looks exactly like it does right side up. So now we're going to do the same thing for cosine. So you can just change your wave to a cosine wave. Alright, what is the y-intercept of cosine?
Well,
1. This time, where do the x-intercept of... where do those happen? The
X-intercepts?
Yep.
At
At pi over 2, or the half pies. Alright, domain of cosine. Negative is the negative to positive infinity, or all real numbers. What about the range? Negative 1 to 1. At what values of x does this function reach a maximum? So what about cosine? Where are the maximums on cosine?
Like the 2 pi.
At the 2 pi's, or the even pi's, right? Because it goes 2 pi, 4 pi, 6 pi. The first one actually happens at 0, and then 2 pi, 4 pi. Or you could go back. Negative 2 pi. 4 pi. What about the minimums? Where are they?
5 pi. No. 3 pi over 2.
3 pi over 2. And then it's going to happen again. Is it at 3 pi over 2?
Pi.
It's at pi.
Oh.
It's at pi. And then the next one happens at 3 pi. And then 5 pi. So the odd pies. The even pies are the maxes, the odd pies are the mins. Okay, what is cosine? Odd, even, or neither?
Even.
It is even. Why?
Because if you go slow,
Fold it.
This one can
fold it over
fold,
the y-axis.
right? This is y-axis symmetry.
They're meant to be.
All right, these two graphs have an awful lot in common. It asks you to compare them graphically. Just off the top of your head, what are the things they definitely share in common? Domain and range are the same. They look almost the same, don't they? I mean, they're the same behavior, there's this wave thing. It's just shifted over, good. So this is the easy way to remember. When somebody puts a graph up for you to remember which one's which. This is a snow cone. Sine starts down and goes